Welcome to Lesson 10.6, Volume of a Sphere. So looking at the final volume formula that we're going to touch on, it is the sphere volume formula, which simply put says the volume of any sphere is 4/3 pi multiplied by the cube of its radius. So volume equals 4/3 pi r cubed. 4/3 multiplied by pi multiplied by the radius to the third power. So just keep in mind, if we're dealing with volume of a cube, or not of a cube, volume of a sphere, we need the radius, not the diameter. So that'll come into play in example 1b here. But first, looking at 1a, we have a sphere with a radius of 7 centimeters. So simply use our volume formula, 4/3 multiplied by pi multiplied by 7 to the third power, and put that into your calculator. 7 to the third power multiplied by 4/3 is 457 and 1/3. So if we wanted our exact answer, it'd be 457 and 1/3 pi centimeters cubed. Or our approximate answer, take the 457 and 1/3 multiply by pi, and it is approximately 1,436.76 cubic centimeters. In part B, we have our sphere with a diameter of 15.6 inches. So we want to take that diameter 15.6, divide it by 2 to get our radius of 7.8 inches. Then use our volume formula, 4/3 pi radius to the third power, 7.8 to the third power, multiplied by 4/3 is 632.736. So our exact answer would be 632.736 pi inches to the third power, or approximately 1,987.8 inches cubed. Then we get into a problem dealing with our layers of Earth. So the diagram at the right shows the layers of Earth. We're assuming that Earth and all its layers are perfect spheres for this problem, even though that's not the case. Use the information in the diagram to approximate the volume of the outer core to the nearest 100 million cubic kilometers. So, in this scenario, we have our inner core and the outer core, which make up the sphere that we're going to look at first. So if we take the volume of that sphere containing the inner core and the outer core, and then if we'd subtract the sphere that's just the inner core, we'd be left with the volume of the outer core. So first, the volume of that sphere, the inner and outer core together. That has a radius of 3,480, in this case, kilometers, because they want us using cubic kilometers, so we'll ignore the miles, and we're using the kilometer measurements, so 1,221 plus 2,259, giving us the 3,480 for that radius. Then it would be minus the volume of the inner core, 4/3 pi 1,221. And I just noticed that these had a couple mistakes. Those should not be the second powers there. Those should say third. Doesn't change the answer. Answer is still the same, but that should be a third power. Apologies. That would be a third power. And these in here should also be the third power. So change all those squareds on there to the third power. Apologies for that. So 4/3 multiplied by pi multiplied by 3,480 to the third power minus 4/3 multiplied by pi multiplied by 1,221 to the third power would give us the volume of just the outer core. So we can simplify that to 4/3 pi, and then in parentheses our 3,480 to the third minus 1,221 to the third. So if we put that into the calculator, doing inside the parentheses first, then multiplying it by 4/3 and multiplying it by pi, our approximate volume comes out to be, and in this case, we'll see a rather large value. It's going to be 40,323,875,140 cubic kilometers. So then, if I wanted to round that to the nearest 100 million, that would just be 40,300,000,000 cubic kilometers. And then moving down to our final piece. So in this case, we have a cylinder with a hemisphere. So it says the figure at the right represents a solid right cylinder, height of 10 meters, with a hemisphere of radius 4 meters removed. Find the exact volume of this figure. So it's a solid cylinder with this hemisphere cut out. And we're finding the exact volume of that figure. So the volume of that figure would be the volume of the cylinder minus the volume of the hemisphere. So volume of a cylinder, which we looked at in a recent lesson, is pi r squared, area of the circle base, multiplied by the height of the cylinder. So we know our radius of that circle base of our cylinder is 4 meters, height of the cylinder is 10, so it'd be pi times 4 squared times 10, minus the volume of the hemisphere, which if it was a full sphere, our volume would be 4/3 pi r cubed. So we'll just take that and multiply it by 1/2 because it's a hemisphere. So then, taking our radius again of 4, we would have 4/3 pi multiplied by 4 to the third power, and then multiply that by 1/2. So doing our math and keeping pi in the answers because they wanted the exact volume, 4 squared is 16, multiplied by 10 is 160. So the volume of the cylinder is 160 pi, minus our hemisphere. So we would take 4 cubed, multiplied by 4/3, multiplied by 1/2, which gives us 128 over 3. So minus 128 over 3 pi meters cubed. So if we then take the 160 minus the 128 over 3, we would get 117 and 1/3 times pi meters cubed. And that would be our exact volume of that cylinder with the hemisphere removed.